For the pointer. I got to load that up to get ready. Right. Good idea.
No, I was late teaching a class.
You believe we made it on time. It's 1:30.
I had no doubt.
You did. I'm sitting here sweating bullets. Okay, let me have your attention, please. Let us begin. Let me have your attention. We had some technical problems that we hope are now resolved. But it's my privilege to welcome you to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker, who is Dr. Larry Foulke, the President-elect of the American Nuclear Society. Larry is also a senior manager at the Bettis Atomic Power Laboratory in Pennsylvania. He received his BS and MS in nuclear engineering from Kansas State University in the early 60s, and then in the mid-60s he received a PhD in nuclear engineering from MIT. He's been at Bettis Atomic Power Laboratory since he got his PhD, which is over 30 years. I've known Larry for 33 years. I first met him at a meeting in Tucson, Arizona in 1970, and I still remember that day that I met him, because he is a very enthusiastic, impressive individual, as you will see today. The title of his presentation is The Status and Future of Nuclear Power in the United States. And so it is indeed a pleasure for me to welcome you to the University of Tennessee, Larry.
Thank you.
You're welcome.
I remember Lee Dodds as a young man. Can you think of that now? Let that stretch your imagination. Oh, those were great days. Those were great days. I was just finishing being a student. You were just finishing being a student and all. And I'm really delighted to be here. It's my intent as President-elect or President of the American Nuclear Society, I want to visit every student A&S section in the United States. I'd like to visit every local section. It's quite a challenge to do that, but I have so much fun of meeting students and talking to you all about things that I sincerely believe in. And my remarks today will be based on an address I gave at something called the America's Nuclear Energy Symposium. It was held in Miami in October of last year. People from all over the northern and southern hemisphere of the Americas came together and we shared thoughts. And Bill Magwood asked me to put together the story of the status and future of nuclear power in the United States. And I thought, gee, wow. Bill, what should I say? I mean, he's kind of sort of the leader of but I spent a lot of time researching, and I engaged a lot of my colleagues from the American Nuclear Society to put together these remarks. And for those of you who have received your February 2003 issue of Nuclear News, you will find that one of the feature articles in that journal, that's just come out, is this presentation. Except I can assure you that if you read the presentation, it'll have much more facts, it'll have much more logic, it'll flow much smoother than I'm sure what I can do here sort of off the cuff. But I'm delighted to be here, and especially to talk to students. Now, Lee said I've been a senior manager at Westinghouse, Bettis, whatever you call it, for many years. Actually, I left Bettis after TMI. They made me director of security. Gosh. They take technical people and put them in all kinds of things. After TMI, I went to Westinghouse Commercial for 10 years, and I was in the training and simulator business. Terrific assignment. Traveling on a Westinghouse expense account. Can you imagine that? All over the world. And, well, I'm back at Bettis now, and they've actually put me in a role as a consultant, taken me out of management in order to give me some release time to do the things that I do. But I remember one of the toughest things to do as a manager was to give performance evaluations. Now, you students get performance evaluations from the faculty all the time. They mark in that grade, they send it back, 75, whatever it is. Do you ever give evaluations to the faculty?
Yes.
What do they say? I wonder if they say some of these things that I understand have been taken off of student evaluations of faculty. This class was a religious experience for me. I had to take it all on faith. He is one of the best teachers I have ever had. He is well organized, presents good lectures, and creates interest in the subject. I hope my comments don't hurt his chances of getting tenure. The teacher improved steadily throughout the course. I think he started drinking, and that really loosened him up. And finally, the course was very thorough. What wasn't covered in class was covered on the final exam, right? Well, I promise you there will be no exam after my remarks today. But my message to you is to convey to you the good news about nuclear power in the world today. And I am convinced, I almost guarantee you, that it is inevitable that this nation will build new nuclear power plants. I see no way to avoid it.
All right.
Here's some of the performance good news that I want to share with you. Increased capacity factor. Do you realize that back not more than, say, 20, 25 years ago, the average capacity factor of nuclear plants in the United States was on the order of 60 to 65%. So those plants really weren't being utilized one-third of the time as a baseload plant. In the year 2001, the average capacity factor of a nuclear plant in the United States was over 90%. 90%, and that's including the time down for refuelings. That's amazing. That is using that asset in a tremendous way. And that increased capacity factor and uprates of existing plants, increasing their power levels by incremental amounts, has given us, over the last 10 years, the equivalent of 23 new nuclear power plants of a 1,000 megawatt electric capacity. 23,000 new megawatts without building a new plant. And that's good news. Excellent safety record. If you look at the trend of significant safety events that go on, and these are things like unanticipated scrams and all kinds of upset conditions, over the last 10 years, the number of significant events, as measured by an NRC criteria, has decreased by a factor of 30. I think last year it was 0.03 accidents per, or let's say significant events per plant. 0.03. Now, I suppose if you're anti-nuclear, what you would do, you would look back at the year before and see it was 0.02 the year before. I see the headline now. 50% increase in significant events at nuclear reactor plants. But it's down a factor of 30. And there's also other data that shows the personnel working in nuclear power plants are working in one of the safest industries in the world. OSHA or somebody puts out statistics on the number of personnel accidents that happen with various industries. The average rate of personal injuries at nuclear power plants is a factor of 10 below the average for all industries. And it's even lower than the accident rates for office workers. This means that our industry has a very keen sensitivity, a keen culture towards ensuring that we operate safely. And that's such a major piece of our public perception. I think we need to get that perception to the public. Reductions in O&M costs. I mean by that operations and maintenance costs. If you look at the average cost of a nuclear power plant in the United States of delivering electricity to a grid, in the year 2001, it was 1.79 cents per kilowatt hour. It's about the same as coal. If you look at the trend of that cost, you would see that trend is very flat. And the good news that that represents is that we call that forward price stability. That means if you're thinking about wanting to have energy in the future, you can count on the price of nuclear electricity. It means something you can count on. Now, if you look at the price of electricity delivered from burning oil or natural gas, a lot of noise, a lot of volatility. You can't be sure what the price of electricity is going to be from natural gas in the future. And I have a personal opinion that it is not the price of energy that hurts us so, because the price of energy in Europe is higher than that of the United States. You all know, if you've been to Europe, that the price of a gallon or a liter of gasoline in Europe, much more expensive. You feel like you're a bargain now when you get back to the United States, okay? And the Europeans live on quite well with these kind of gasoline prices. The thing that bothers people, in my opinion, is the volatility involved. It's when the price of electricity changes from this level to a factor of 2 higher over a period of a week. How that disrupts our lives. Suddenly, you can't ship those bananas or the oranges from Florida and California to our produce markets, and what we're so accustomed to. So it's the volatility that gets our nation upset. and nuclear guarantees us good forward price stability. These costs that I quoted, 1.79 cents per kilowatt hour, that's the cost of the fuel, the operations, and the maintenance. That does not include the cost of writing off the construction loan that you had to take to build the plant. But what makes nuclear plants such a valuable asset today is that most of those costs have been written off. And so those, I will call them the conglomerates, the Exelons, the Energies, who have bought all the nuclear plants, these are assets that are just delivering electricity almost for the price of operations, maintenance, and fuel. So Wall Street now is looking at Energy and Exelon and Dominion and what do you call Pint? Larry Miller wears something called Pint. Okay? TVA. They call themselves something else now. But that's why these companies are so favorable now in the eyes of Wall Street. It's because they've got assets that deliver like cash cows. That's part of the good news. Reductions in radioactive waste generation, reductions in worker exposures, avoidance of pollution. You know, I think I have a statistic here which says that since the mid-1970s, nuclear energy has enabled the United States to avoid emitting over 80 million tons of sulfur oxide, 40 million tons of nitrogen oxide, and of course you all know the carbon dioxide story and the global warming. I'm going to say something I hope doesn't offend you and all, but nuclear power is delivering us clean electricity, and we do not use the biosphere as our sewer. Almost any other form of energy generation today, what do they do with their waste? Do they worry about Yucca Mountain? No, they just dump it to the biosphere. And yet nuclear waste, if we sequester it, we track it from the get-go. And what other industry has been paying a premium on every kilowatt delivered in order to put into a fund to take care of their waste products? It makes the other industries, perhaps, that make energy seem almost irresponsible. So, bang, there you go. Well, besides excellent performance, you know, you buy used cars, and they call them pre-owned cars. Well, there is a tremendous market out there for pre-owned plants. Some of these conglomerates have gotten some real bargains of buying these plants from these utilities that only operated one plant. And now you put these in a group of nuclear utilities that are nuclear plants under one utility that knows how to operate those things. And that's part of the reason for the safety and the high performance and the capacity factors. Manpower issues, I should be more sensitive and call that the workforce issue. The workforce issue is being addressed. If you've been following any of the American Nuclear Society activities over the last 2 or 3 years, you know that workforce issues have been one of our major thrusts, as is the whole industry. In fact, all engineering industries are facing a workforce issue today. There's too many people, in my opinion, going into, again, I hope I don't offend you, business and law and the soft sciences, as opposed to the engineering sciences which deliver new products and new profit to our nation. Nuclear engineering has been suffering, but the good news is that the enrollments are coming back. I'm so impressed with the enrollments here. 93 undergraduates, 63 graduate students. I think it's fantastic. I think that's second only to the story of Texas A&M in the United States. Texas A&M now has more undergraduate, baccalaureate, that's redundant, undergraduate nuclear engineering students today than they had back in 1993. Yes, we've gone through a low, but it's coming back. The workforce issue is being solved. I'm more worried about the knowledge retention, the specialized knowledge retention. We got people retiring today who's got all that knowledge in their heads about heat transfer of liquid sodium in small pipes. Maybe that's not written down in textbooks, but those people are retiring. And our nation is losing that specialized knowledge, and that's a critical issue I believe our issue is facing. I liken that to the conservation of energy. I liken the workforce issue to the conservation of mass. A most important one is the conservation of momentum, and that's where I look at the infrastructure. The infrastructure of our industry is crucial. I visited Oak Ridge yesterday. I went to Orella, that's the Oak Ridge Linear Accelerator that they use to measure cross-sections and develop new nuclear data. That's an important piece of our infrastructure. The university reactors are important pieces of our infrastructure. It's so important that we keep the momentum and keep that infrastructure strong. And under my leadership of the American Nuclear Society, we're going to focus more on the issues of knowledge preservation and the infrastructure preservation because the workforce issue is being solved, in my opinion. Upswing in university enrollments, that's what I talked about. National energy policy is pro-nuclear. Bush, Cheney, Depending on who you are, what political party it is, you may criticize or you may not criticize, but now we have an administration in Washington that is not afraid to use the N-word. And in fact, they believe in the N-word, and for very good reason, of course. We've made progress on a geological repository. It's not a done deal yet. I think there's going to be a lot of fisticuffs over the next decade as the state of Nevada, who legitimately feels put upon, is trying to use the courts now to stop putting spent fuel. I will not call it waste, or putting spent fuel in Yucca Mountain. Do you realize that the stuff that's going in Yucca Mountain has a fissile content that could deliver energy to our nation for years? And I think in your generation, or maybe your children's generation, you're going to wonder, why did those people put all of that spent fissile material in the mountain? Thank God we didn't cover it up. I predict, maybe you'll quote me someday after I'm gone and you're an old and talking to students, you'll say that, I remember when Larry Foulke told me that they were going to build a reprocessing plant right next to Yucca Mountain. And then they're going to build a fuel refabrication plant right next to Yucca Mountain. And Nevada is going to become the richest state in the Union because of having all this capability. That's probably what the future holds. But if you were in Nevada, I can understand how they feel. I can understand it because one of the things that it's shown that when people oppose something, they oppose it generally for two reasons. One is that there is a real risk involved. And the second one is they feel like they have no control over their destiny. Sure, they smoke cigarettes, it hurts their health, but that's under their control, so they accept that. But now with nuclear power and the spent fuel in Yucca Mountain, while these folks are imposing something on me, I have no control over what's being done, and I rebel against that. And I think we would all rebel against that. Just think, what if the government came to you and says, we're going to build a wind power windmill in your backyard? I'm sorry, it's going to detract from the beauty of your house, and yeah, birds will be killed and they'll fall in your backyard and you'll have to take them out, but it's for the good of the nation. What would your attitude be? Oh yeah, come on in. Or, why me? So you can understand how the people of Nevada may feel about the geological repository. But I think the sentiment is turning. There are many polls that show the man on the street who's not in a political office, who feels like it's a red badge of courage to oppose this. The people of Nevada, I think by and large, are ready to accept this because there's a lot of benefit that can come to their state because of that. Improved licensing process, 10 CFR 52. One of the big uncertainties of the past has been the licensing process. First, you had to get a construction permit and hold hearings and let everybody, grandmother and all the things coming out of the woodwork saying, oh, watch out for the salamanders. We got to save the newt. We got to save the sparrows. And there would be those hearings, and there was delays. And then would come a licensing of an operating license. Have to go through the whole cycle again. It gave great uncertainty to the process and the timing to get the licensing done. And as I'll show you with some figures in a few minutes, that delay can cost a lot, and the uncertainty can cost a lot. But the new 10 CFR 52 licensing process, it's a one-step construction operating license. And there's a lot of other provisions as well that allows the utilities to pick a site and do a lot of the things that took a long time in the past. The only difficulty is this hasn't been tested yet, so we don't know how good it's going to work out. That's the good news. And another piece of the good news is that, our national well-being depends upon abundant energy. There's a correlation that shows, a very strong correlation, that shows that longevity or life, of your lifelong, how long you live, is a strong function of how much access you have to energy. And energy is good. Conservation is good because waste is bad, but that doesn't mean that energy is bad. Because everything we do in our life requires energy. We grow the grain using energy. We thresh it. We ship it. We grind it and turn it to flour, all by the use of energy. We bake the bread by use of energy. Everything in our homes today depends upon having that energy to do these things. Yet if we didn't have abundant energy, our lifestyle would be quite different. The good news is that we'd all be fully employed. There would be no unemployment in the nation because we would all be spending 24 hours a day, 7 days a week chopping wood simply to subsist and keep our lives together in existence. And other things, Social Security would no longer be a problem because the age to our lives would probably go down from 80 years to 65 years, and so Social Security would no longer be a problem. That would be the good news of not having abundant energy, but of course I don't consider that good news. It is good news that we have this energy, and the fact that we have it and so much of the world does not have it is not good news. Do you realize that there are 2 billion people on this earth who do not have access to ample supplies of electricity? I think it's about 1.5 billion people who don't have access to safe drinking water. How would those people like to have the energy and the lifestyle that we have? It's almost a sin for us to live with the lifestyle that we have, and there's so much of the world that doesn't have safe drinking water or access to electricity. What does this mean? This means that the energy use in this world is going to increase substantially. And what kind of energy is that going to be? Coal? Yes. Clean coal can help. Solar? Yes. Solar can help. Solar has its place. Wind has its place. I do not knock wind and solar. But it's the analogy between having the difference between feeding a family and feeding a nation is quite different. Solar and wind can deliver kilowatt chunks to specialized uses. But if you want to feed a nation, it takes gigawatt chunks, and you get that only from the base load power plants that nuclear energy can deliver. Energy increases the quality of life, and energy frees us to be creative. I'd hate to spend all my days chopping wood to keep my house warm. Because of energy, I have the time to create and be creative. I've told you all that good news. And you all know from your nuclear studies that nuclear energy can deliver secure, reliable, environmentally clean, cost-effective energy. But there have been besides all that good news, there have been no new plant orders in 25 years. That doesn't seem logical, does it, after the good news I've told you? Well, there are some barriers to building that next new plant, and I'm going to cover those now. One barrier is that there is no power shortage in this country on the average today. Maybe there will be power shortages in places. California had its power shortages. They had their problems. They built a lot of overnight, quick construction, combined cycle gas turbine plants. And now California has boosted its energy production up to the point where there's no longer a power shortage in California. I think this next, yes. National Energy Research Council, this is the outlook for electricity supply in the future. The red line shows you 3 projections of the capacity of electrical generating capacity on the average in the United States over the next decade. The green lines show you the expected demand under certain various scenarios. And you can see that the demand curve does not start to push the capacity curve until sometime after the year 2006. So, why worry? We got 5 years. No, I guess it's 3 years now. Well, it takes some time to build good new baseload plants. But that is one of the barriers, is that there's no perceived power shortage. Low natural gas prices. I got mixed feelings here. I'm from Kansas. I still own a farm in Kansas, and we got a gas well on my farm in Kansas. And I love that check that comes every month for the gas. So I'm for natural gas. But natural gas has its problems. This is some new material I've just taken off and I've never used before except with you here. We are facing a future natural gas crisis. And I have taken this from EnergyBusinessWatch.com. If you want to take that down and go inspect some of these things for yourself, you can. But the gas fields that we have in our country today are aging. And the new wells that we're putting in are not as big in terms of its capacity and the pools that we're getting into. And the half-life for new wells is less than 12 months. There is a limit on our ability to ramp up our imports, just as anything that you build today is not in my backyard. That's the same way with natural gas terminals. If you want to have liquid natural gas come in from foreign countries into your port, Well, the people there, they oppose building those new terminals. And the cost of building a new natural gas tanker is not cheap. So they have their problems. Once upon a time, natural gas used to be used for industrial uses, making chemicals and such as that. But now a lot of our natural gas is being used to generate electricity. And the prediction by Energy Watch is that the natural gas production in our country will be at its lowest level in 15 years this year. And the rate of demand, because it will increase, because we have all these new natural gas combined cycle turbine generators generating electricity. What does that do to demand? I've been telling you that the supplies are going down, the demand is going up. Economics 101 says that. Prices are going to go up. And electricity generation is predicted to drive prices to record levels of an already volatile fuel supply. Energy Business Watch concludes. These are the conclusions, if you can read them. These are nice slides. I used some slides last night that weren't nearly as good, but I had a professional help me with these. And now they're much better. Okay? This upward shift will not be short-lived. It's going to last for a while. And that's going to put a lot of pressure on the utilities to deliver competitive electricity. In fact, I believe that the price of electricity in some areas that have installed these combined cycle natural gas electricity generators are going to be under great political pressure to reduce prices in some way. Heck. Whoa, this must be one of these revealing, yes. PowerPoint, God, the power of PowerPoint. Lack of momentum. If you haven't built a new plant in 25 years, there's a certain inertia that sets in. It's going to be hard to get this thing started again. You notice not only have the nuclear utilities kind of combined into conglomerates, but look what's happened to our vendor base. I think Westinghouse bought combustion. BNFL, British Nuclear Fuels Limited, bought Westinghouse. Big fish keep eating littler fish, and we keep getting shrinking in the number of vendors that we have. Framatome, Siemens have gone together. I think General Electric may be the only American supplier now, and they're really mixed up with Japan. So we have a lack of momentum of getting this thing going. Price-Anderson, as many of you may know, this is the indemnification, the liability covering act that was passed back in the early days, about the time of the Atomic Energy Act. And this doesn't cost the nation anything, in my opinion. I believe I've started to understand this more and more. And I won't go into the details of Price-Anderson, but right now, the current Price-Anderson legislation has run out. It ran out last August the 1st, and it has not yet been renewed. That doesn't hurt plants that are already covered by Price-Anderson. The existing plants are still covered. But any new plant would want to have this liability indemnification that amounts up to around $9 billion, up to $90 billion in the case of an accident. But both the Senate and the House have agreed that they want Price-Anderson, so I think it's just a matter of time until the Congress gets around to passing Price-Anderson. So I don't think that will be a barrier. Terrorism and security, is this a barrier? Well, it is in the perception of the public, in my opinion. You hear all kinds of things about, oh my God, what if this fully loaded jet balloon would crash into a containment? Well, the public is concerned about that. Now, an EPRI study, the Electric Power Research Institute, has just completed a study in which their analyses by an independent contractor showed that these planes are somewhat like big tin cans. And when a tin can crushes into an immovable object like a reinforced concrete structure, like a containment, the can crushes and the containment is not damaged. But the public doesn't understand that. Terrorism. My gosh, what about the dirty bomb? Well, we know how to clean up radioactivity. Any health effect that would be caused by a radioactivity release wouldn't show up for at least 10 years or maybe 20 years as some latent cancer fatality. Terrorists are not going to be satisfied by doing things where it takes 10 years to see a public health effect. A smart terrorist has much better choices than a dirty bomb. And as you all know, we probably overestimate the consequences of a particular dose because of our linear no threshold hypothesis that says if 1 million people each get one gamma ray, 1,000 people die. Well, you know just from logic that that's bunk. But indeed, That's the kind of estimates that are used very conservatively, but that gets the public quite upset. But the public has to be educated. And we have the job, really, because we have the facts. We wear the white hats. And in the old cowboy movies, the people with the white hats would go out and they would win in the end. And I know that our facts will prevail at the end of the day against all the misrepresentations and the hypothetical impending doom type of situations that the anti-nuclear people would have the public believe. Waste, or I'll call that spent fuel, that's largely a public perception problem as well. And I believe one of the biggest benefits of moving towards a geological repository in Yucca Mountain is the public may perceive, this waste problem has finally been solved. Well, it's really solved today. Our waste is safe today where it is. But public perception is a big part of what we're trying to do here now. Proliferation concerns, as you may know, no, you're all too young, but Ron's too young. Back in 1970s, I think, our nuclear engineer president, Jimmy Carter, he said, I'm very worried about recycling plutonium in reactors because what if somebody would steal this reactor-grade plutonium? And, back in those days, we thought, well, anybody could take this stuff, go to their garage, and make a nuclear weapon. Well, I can assure you it's not that easy. And I can also assure you that reactor-grade plutonium is probably the worst choice for a self-respecting terrorist. Weapons-grade plutonium is what could really make a nice bomb, but of course that's well protected. Reactor-grade plutonium is filled up with so much gunk of other plutonium isotopes that it does not make a good device. And today, the easy path to proliferation is through enrichment of natural uranium. Once upon a time, if you wanted to enrich natural uranium to get highly enriched uranium, you had to build a gaseous diffusion plant, and that was a big deal. I guess you all know that living here next to where those gas diffusion plants were built. But today, laser enrichment, centrifuge enrichment, this is not rocket science anymore, and it's not that huge, and it's not that expensive. The easy path to any weapon today by any country intent on doing this is mining their own natural uranium, building a laser enrichment capability, and enriching their own uranium. Plutonium recycle is not a problem. That's another lecture. We have lingering concern over safety. Now, I end what I call these 10 barriers that I see right now with one which I think is the barrier that is preventing the next nuclear power plant from being built, and that is the financial markets. The next new plant, the first new plant that we build, it's probably going to cost, for a 1,000-megawatt plant, it's going to cost on the order of $1.6 billion, or about $1,600 per kilowatt electric. And we have a terrible record in this industry. No, let me say, we have a record in this industry as perceived by the Wall Street bankers that we can't count on these nuclear people of being able to build that plant within a definite time because of all these environmental concerns and the way the regulators permit everybody to step up and stop a plant. And they know that Shoreham, a plant built, pristine, ready to go, never operated, never delivered a megawatt of electricity. So if you're a banker, and I come to you and say, I want to borrow $2 billion, Ron, okay? I won't give you any return on that $2 billion for 4 years. And in that 4 years, the administration in Washington may change. What are you going to do as a banker? You're going to say, nah, I don't think so. That's too much risk for me. I'm not sure when I'm going to get my money back. And the major message of my story today is that these financial barriers can be overcome to build that next new plant, and the right organization to do that is the Department of Energy, and I'm telling them that message. Now, I fear you may not be able to see this, so I will describe what I'm trying to illustrate here. Here you see the capital cost of two 1,100 megawatt electric plants plotted on the ordinance. On the abscissa, we have along here the first pair of plants built, the second pair of plants built, and so on. Now, it's important to note that the nth plant out there, that cost is on the order of $1,000 per megawatt electric, which everybody agrees, boy, we could guarantee that delivery price, we'd be building nuclear power plants right and left. But today, we know that that next new plant is going to cost a lot more. Why? Well, There's going to be some first-of-a-kind engineering that's got to be paid for on that first new plant. There's going to be a learning curve that means costs will come down as you make more and more plants. Plus, there's going to be extra financing costs because if you do get that loan from that Wall Street banker, yeah, I'll loan it to you, but I'm going to charge you a little more interest. So there's going to be more risk, and that causes that price to be that high. Here is a table which I think you can see, and what this illustrates is the sensitivity of the internal rate of return. This is what the bankers will look at as a function of some of the variables. Okay? Let's look at 4 different plant costs, $1 billion, $1.2 billion, $1.4, and $1.6. These are the costs of what I would call the overnight capital costs. It's here the EPC costs, the engineering, procurement, and construction costs, independent of interest or anything like that, you see. All these financing costs plus development, startup, contingents, and all that thing really takes these overnight capital costs up to numbers like this. Or like it's like $1.9 billion or $1,943 per kilowatt hour. Okay? 4 different plant costs. Now what you see here, this IRR is the internal rate of return. And to the banker, I'm not a banker, I'm a neutron physicist, I understand the banker looks at internal rate of return. And if you can show that you can deliver 10% internal rate of return, the project is very interesting. Okay? So we look here, where do we get that 10% or greater internal rate of return? Well, it depends upon what you can sell the electricity for when you put this plant online. And so the variable you see across the top there is the electricity rate in dollars per megawatt hour. And you can see if I build this plant and I can only sell the electricity for $25 a megawatt hour, there's no way that I'm going to recover that investment or get the financial people interested in it. Today's electricity prices, and I just took this off the web this morning because I knew that Lee or somebody would ask me after I explain all this, well, what is the price of electricity today? This is off the Energy Information Administration webpage of DOE, and the spot prices, if you like, for electricity at the close of business on February the 3rd, the average over the United States is $48 per megawatt hour. Hey, that's above the 45. And look, at $45 a megawatt hour, if that price holds, I don't care if that plant costs $1.6 billion overnight capital costs or not, because I can get an internal rate of return on that investment of 11.4%. Not bad. So there's good news. The Department of Energy is trying to help. The Department of Energy has a program they call DOE 2010, and their aim is to do those things necessary to build the next new plant by the year 2010. And what they've done, they started an early site permitting process where they're splitting the costs with 3 utilities to go off and look at potential sites where this plant would be built. And let's get that behind us so that doesn't delay us when we really start to go. Okay? We're going to start to demonstrate this new licensing process to prove that it works. That'll get some more of the uncertainty behind us. And, of course, they're putting money into researching advanced technologies through a whole alphabet soup of acronyms, NERI and NEAR and NEPO and what have you. These are all very good things, and I applaud them and I support them. But DOE 2010 may not be enough if you really want to build a new plant by 2010. And it's not just the DOE. We can't say, whine, government, you got to do something for us. My view is that the industry, these conglomerates, the Exelons, the Energies, the Dominions, they've got to say to the government, we must build new nuclear power plants for the good of our country to get secure, reliable, price-stable, environmentally clean energy. You've got to help us, DOE. Here are some things you've got to do for us. And that's what I want to indicate as what some of these things should be. But first, here are some of the financial issues. I'll quickly cover them. The banker, Ron Peavy, he says, I'm not going to loan you that money. I don't have lazy money lying around that I can just throw at any project. I've got to be sure that you're going to deliver. So the financial markets aren't prepared for the money. Power company are concerning about earnings dilution. The stockholders are everything today. If a utility announces some bad news on a Thursday afternoon, stock markets will react the next day. So these power companies are very worried about their balance sheets, that they just can't put out the money. Concerns about delays in construction. If I start building this plant, how do I know it's going to get done by the time? Concerns about recovering costs in a deregulated market. Once upon a time, the utility's job was to deliver reliable electricity, and I'd get to recover all my costs of anything I build. That's not true today in many parts of the country because now many utilities are unregulated. Unregulated. They compete on a spot market daily basis with every other form of delivering power. And what if they get that new plant built out there in the year 2008 and they have no customer? Because our nation is really not geared to connect all these electrical grids to make power in Florida and sell it in California. Our grid is ancient, so you can't move power around the country very well. So if you plop that power plant down in Florida, how do you know that there's going to be a market for that power plant in Florida? Okay? Here's a big one. The playing field is not level. There are no financial credits for the non-financial benefits of nuclear power, the environment, the security, the reliability. That would be a big one. Now, here are these issues. What can we do about them? The government could provide an equity investment. You all realize that we've been paying in like $0.1 of a mil per kilowatt hour since time began for the waste fund to take care of our waste. Well, that fund amounts to $14 billion today. I would like to suggest that the government should take $2 billion of that $14 billion, put it in an equity investment in building that first new plant, and as that plant gets online and starts operating, the government will get their money back. Standby credit facilities for delays. So some regulation comes along, somebody's worried about the wetlands, and they say, stop, let's go to court. We're going to try to stop you. Let's have then the government, if the cause is related to a government regulation, let's have the government pick up the interest on that construction loan. Power purchase agreements. If I'm going to put this plant in Florida and start delivering power in 2008, give me a credit-worthy entity who will say, I promise to buy 50% of your power output for 3 years at this price. Boy. When I talked to Harold Ray, our president, about his issues and this thing, he said, Larry, the most important thing that we need now is power purchase agreements, to one man's opinion. Financial credits for non-financial benefits. When that utility executive wants to build a plant, goes in the boardroom and says, I want to build this plant, we have no way today to take into account the non-financial benefits from nuclear power. And that board is only interested in one thing, and that's money and the profit. Impact of these mitigants. Let's take a base case of a $1.2 billion overnight capital construction costs, $1.2 billion. We'll assume fuel cost is 5 mils per kilowatt hour. We'll sell the electricity at $35 a megawatt hour, a capacity factor of 90%. We're going to borrow half the money. We're going to put in 50% of it in from our equity, and the interest rate on a 30-year loan will be 8%. That internal rate of return is 9.3% under those conditions, and it doesn't quite make it. If we lower the EPC cost, case A, so it's a $1 billion, well then it's a 10.7%, so other same conditions, and then finally if it goes up to $1.6 billion, it doesn't quite make it. Now, I want to emphasize, these are not my calculations. These studies that I'm showing you were done by Scully Capital Services. They were engaged by the Department of Energy to make an examination of the financial case for building the next new power plants. So compliments of Scully Capital Services and Larry Scully, I'm sharing with you these results. Here's another sensitivity analysis. The base case is the same, but this time we're going to see how much do we have to increase the price of electricity in order to make this feasible. I only have to increase it to $36.40 to get that 10% IRR. Or what is the effect of a little smaller interest rate? Smaller interest rate of 6% almost makes it with the other same conditions as the base case. Other sensitivity analysis. What's the effect of a government power purchase agreement of $50 per megawatt hour for 3 years at a 90% capacity factor? And that gets us up to 10%. Or here, to me, is the easiest one, that last column, the effect of emissions credits. If it only were a 4% tax on the price of electricity to give nuclear credit for its non-emissions. That is enough to take that $1.2 billion case up to make the right kind of internal rate of investment. Now, when I mentioned these things to Bill Magwood, the DOE guy that you all know or know of, he says, Larry, we can't ask for these things. I think this is what he said. Bill, if you're watching, I'm sorry if I'm misquoting you. But, you know, some people will say, I won't say Bill Magwood, I will say some people will say you can't say these things because the anti-nuclear people will take all this information to show to say, see, nuclear power can't make it without help. You can't do it on your own. And we don't want to feed the anti-nuclear that kind of information. Others may say, but we won't be able to deliver all these things, and then you're dead. I say, no, we're not dead. Give us just one or two of these mitigants, and we'll make it work. Bottom line, I believe industry must ask the Department of Energy to mitigate the financial risks for building that next new plant. And I want the vendors to share the risks. In the past, when new power plants were delivered, the vendor just got the money and the utility took all the risk. But we know today that Westinghouse goes together with Dominion for operations, and Westinghouse says, I will give you a service contract, and if your capacity factor reaches this amount, this is how much I get paid. But if you don't do well, we don't do well. I want to see the vendors step up and say, we're willing to share the risk with you, Dominion. That's the new business model I'm talking about. Now, as I said, people will say, you can't do this, or the anti-nukes will say, see, you can't make it on your own. But I really sincerely believe energy independence, getting away from dependence on foreign oil, using nuclear power to make hydrogen, environmental quality are too important to leave to the short-term market forces of deregulated utilities. We have to have the vision to look ahead and see what our nation is going to need in the future. So, what kind of technology is this going to be by 2010? It's going to be probably and most likely a water-cooled reactor because that's the technology we know today and that's the technology we can build quickly. Gen 4 is great and it's very promising for the long term, but it does not solve the problem by the year 2010. And, you know, nuclear power is an international issue because an accident in one country hurts things in every country. So the future of nuclear is international, and that may be the last slide, and I thank you for your attention. Did I make it under the time?
Time for questions and comments.
Yes, sir.
I was wondering if you have any idea, like a rough estimate of how much Yucca Mountain is going to cost, including the shipping of the waste there, like installing, like just a rough estimate.
I believe there are estimates out there. I hesitate to say a number because I would probably not do the number that is already out there, but I can say that it's in the billions of dollars. In fact, it's in tens of billions of dollars. $30 billion. That's my thank you prompter. But I have another Foulke unsubstantiated opinion, I'll call it an FUI, is that I believe that future generations will look at the money that we're spending on Yucca Mountain and they'll say that's the greatest example of government waste in the history of our nation in terms of dollars spent per lives saved. We're not saving that many lives by worrying about the radiation from spent nuclear fuel. If you want to save lives, there's much better places to put those billions of dollars.
Other questions or comments? Well, I'll ask a question, and it really it's independent and separate from almost your presentation today. But where Larry works is a very interesting place, and they've been the leaders in nuclear technology, reactor development and design for 40 plus years. And I know that not only Bettis and Capel, but other nuclear labs and organizations in the United States are looking for talented young people. And I thought we should give Larry the opportunity to make a pitch for Bettis and Capel and just tell briefly what you do there and the interesting stuff, the unclassified stuff.
Of course. The Navy wouldn't let me come, the naval reactors wouldn't let me come talk to you if they thought I would talk about classified stuff, which I won't, of course. But I guess a couple of things I want to say, and probably more, and I'll think of them tonight. If the students come, we can talk more about these things. One of the most satisfying parts about working at Bettis or Capitol is the fact that the focus, and I don't want this to be misinterpreted, but we're not the real world because we're not driven by the bottom line. So much of what we do in this world today is driven by you got to make the money, you got to deliver the product. And that's great, it's great motivation. But the motivation for the work done in the Naval Reactors Program is the quality of the work. Because we may have your cousin or your uncle out there in a nuclear submarine. And our nation simply cannot stand, the United States Defense Establishment could not stand the loss of the submarine because of some nuclear accident. So we've got to be right, and the focus is on the quality of the work. I've worked in both the commercial industry and the DOE Naval Reactors Laboratories, and I can assure you there's some great satisfaction in being able to do the work in such a way as that you know it's right and it's the best you can deliver. There's a satisfaction with that, and I pass that to you. Second thing I want to say, I do believe that the Naval Reactors Program proves that you can handle nuclear materials and components safely. If you consider that in our over 50 years of existence as the Naval Reactors Program, with Bettis and Capitol being its primary laboratories, our nuclear submarines and surface ship have steamed over 126 million miles, 5,300 reactor years of experience. Not one accident, not one incident, not one event that has released a measurable quantity of radioactivity to the environment. Who says nuclear power can't be done safely? I think the Naval Reactors Laboratories are living proof that this can be done. And I think our commercial industry is taking that same attitude towards these. What you need is the unchanging core values of a culture that is aimed at safety, safe operation, complete design, and accuracy in your work. Thank you.
Okay. Well, any other questions or comments? Tom?
Look at your capacity chart and the demand chart and so forth.
Yes.
Assuming that the regulations allow you to do so, what would be your estimate of how many nuclear plants will be built in the next 25 years, for example, in order to satisfy that demand?
That's a good question. Last night I showed a figure that showed that if the energy needs in this country were to grow only at the rate of 1.8% over the next 20 years, that we would need the equivalent of 343 new 1 gigawatt, i.e. 1,000 megawatt electric plants. 343 over 20 years. The actual energy growth in our country over the last 10 years has grown at 2.2%. So that 1.8% is very conservative. 343 new plants. Are you going to build 343 new? Does our industry have the capacity? If we were called upon even to build half of those, you're talking about building 170 new 1,000 megawatt plants? It staggers me to think that our industry could gear back up to do that. But the answer to your question is that I believe that the nation will demand that at least 20% of the new capacity is nuclear. Because nuclear today is delivering 20% of this nation's electricity. 1 out of every 5 homes, 1 out of every 5 businesses is fueled by nuclear energy. And just to maintain that, 20% of what? The 343 is 0.2 times 34, 68 new nuclear power plants. That's my prediction.
Okay. I see really several new faces in the audience. We almost had a full house today. You really brought them in. Those of you,
great advertising.
Those that are new probably do not realize that after each one of our colloquium presentations, we go downstairs and have a party with refreshments. And everybody who's here today is welcome to join us at the party downstairs for refreshments. But before we adjourn and do that, let's express our appreciation to Dr. Foulke one more time. Downstairs.
Hi.
I'm Scott Pine.
Yes, Wes. I've heard your name.
ANS program.
I have heard your name.
Yeah. I sent an email probably about a year ago when I first started being the program chair, because you were still on the executive committee.
Okay.
Yeah, it was the executive committee.
Right.
You were list. I remember Brian